January 1943. Dawn breaks over Akron, Ohio. The sky is pale, a thin winter sun glinting off smokestacks that stretch toward the clouds. Inside the massive factory floors, the hum of machinery is relentless. Conveyor belts clatter, mixers churn, and vats of chemicals hiss as they heat. Men and women in gray overalls move with purpose, their eyes fixed on gauges, valves, and the steady rhythm of production. Across the Pacific, Japanese engineers pore over intercepted reports and telegrams, their faces tight with disbelief. Numbers and specifications, tons of rubber produced, new polymer formulas, production lines running day and night, seem impossible. How could the Americans replace the natural rubber loss when Southeast Asia fell under Japanese control? Every calculation seems to defy expectation. Every report a challenge to their understanding. On the factory floor, a foreman taps a clipboard, checking the daily output. Tires, hoses, aircraft seals, synthetic rubber in every form, roll off the lines, destined for ships, trucks, and planes that will cross oceans to battle the Axis. The pace is relentless, the scale unprecedented, and in Japan, the reaction is clear: shock, disbelief, and a dawning awareness that the war is shifting. The stage is set, and the battle of industry has already begun. By early 1942, the Pacific theater had shifted dramatically. Japanese forces had swept through Malaya, the Dutch East Indies, and Burma, seizing the world's richest natural rubber plantations. Rubber was not merely a commodity. It was the lifeblood of modern mechanized warfare. Tires for trucks, tanks, jeeps, and aircraft, seals for engines, hoses, gaskets. Every inch of military hardware relied on it. Without a steady supply, vehicles would stall, aircraft would fail, and armies would grind to a halt. For the Japanese, control of the plantations seemed absolute. For the United States, the loss was a strategic emergency, demanding solutions beyond conventional thinking. The U.S. had anticipated shortages, but the scale of Japanese occupation accelerated the crisis. Before the war, the United States had relied heavily on imported natural rubber. Domestic production existed only in small experimental plots, insufficient for civilian needs, let alone the demands of a global war. By mid-1942, the government recognized the stakes. The War Production Board created to centralize and oversee industrial mobilization, declared synthetic rubber a top priority. Every laboratory, every chemist, and every manufacturer capable of polymer production was mobilized. Initial experiments with synthetic rubber dated back to the 1920s and 1930s, but these had produced limited results. Compounds such as Buna and GRS were known to chemists, but scaling them to industrial production remained elusive. By 1942, the challenge was not scientific theory, but logistics. Laboratories that had once handled grams of polymer were now asked to produce tons, to standardize processes, to guarantee uniformity, and to integrate the product into a supply chain spanning factories, railroads, and ports. At the same time, American engineers faced the human challenge of training an unskilled workforce. Men and women, some drafted from unrelated industries, were introduced to chemical synthesis under pressure. Safety protocols were strict, but often overwhelmed by the pace. Explosions and chemical burns were constant risks. Yet, a culture of innovation and relentless efficiency developed. Blueprints were revised overnight.
This schematic shows the new assembly procedure.
And production lines designed with modular precision.
Very tight.
By late 1942,
precision is critical.
Pilot plants were churning out synthetic rubber on a scale that had been impossible just months earlier. Across the ocean, Japanese observers struggled to reconcile the reports they intercepted. Technical diagrams, production statistics, and dispatches detailing the daily output of American factories appeared almost fantastical. Their engineers and officers, accustomed to thinking in terms of natural supply limitations, could not comprehend the magnitude of what was happening. Each weekly report seemed to defy expectation. Output numbers exceeded predictions. Facilities expanded faster than calculations allowed, and labor shortages were solved with sheer organizational ingenuity. What should have been a crippling shortage was now being countered by an industrial surge that seemed almost inexhaustible. This industrial achievement was not limited to chemical production alone. Supply chains were reorganized.
Pressure holding steady at 250. Watch the seals.
From factories to military depots.
Opening auxiliary valve. Steam is
prioritized. ports
Confirmed.
modernized,
All gauges
and
stable.
standardized containers implemented. Trucks and ships were loaded with precision, ensuring that every pound of synthetic rubber reached its destination without delay. From the smallest gasket to the largest aircraft tire, synthetic rubber became the invisible artery, keeping America's mechanized forces alive and mobile. The strategic consequences were immediate and
Tires
profound. U.S.
Won't last
forces,
another convoy.
particularly in the
Hoses are
Pacific
cracked,
Theater,
too. The
could
whole fleet's
maintain
worn down.
mobility, deploy
Get the
armored
spares.
units,
We can't afford
and
delays.
keep aircraft operational in conditions that would have immobilized any opponent reliant on natural rubber. The Japanese, who had counted on cutting off this lifeline, began to realize that their control of the natural resource was no longer decisive. The very weapon they had sought to dominate, the global rubber supply, was now being neutralized by American innovation. In this context, the battle for synthetic rubber was as critical as any frontline engagement. Factories and laboratories became the hidden battlefield, with chemists, engineers, and laborers acting as soldiers in a war of industry. Their successes would ripple across every engagement. Amphibious landings, jungle campaigns, armored advances. While the front lines drew attention and headlines, it was in Akron, in Houston, in Baton Rouge, and in dozens of other industrial centers that the decisive efforts of the war were being quietly executed. And as these processes scaled, the U.S. was not merely replacing lost resources. It was creating a system so resilient and adaptable that Japanese engineers would soon confront a reality they could scarcely believe. The Axis' supposed advantage in rubber had been erased, not by conquest, but by ingenuity and sheer industrial power. This foundation of industrial mastery set the stage for the angles of the story: human, technological, tactical, leadership, and enemy perspective. Each perspective would reveal a different facet of how synthetic rubber reshaped the war. In Akron and Baton Rouge, the human story of synthetic rubber production unfolded with relentless intensity. Chemists, many in their 20s and 30s, stood over vats of heated polymers, carefully monitoring temperature, viscosity, and chemical reactions. Their hands were stained with synthetic compounds, and their faces reflected the strain of unrelenting deadlines. Supervisors called for output quotas that had previously seemed impossible. Entire shifts worked around the clock, fueled by coffee, determination, and the knowledge that every tire and hose they produced would sustain soldiers thousands of miles away. Meanwhile, Japanese engineers, thousands of miles across the Pacific, struggled to comprehend the reports reaching Tokyo. Figures and diagrams detailed production numbers, chemical compositions, and new formulations that seemed to defy logic. The idea that a nation could replace natural rubber with an artificial substitute, and at such volume, was almost inconceivable. Diaries and intercepted messages from Japanese technical officers reflected frustration and disbelief. They have no plantations, yet they produce what we cannot, one report noted. Their shock was mirrored in meetings where officials pored over schematics, searching for errors, trying to understand how the Americans had achieved what they assumed impossible. This human contrast, American perseverance versus Japanese incredulity, set the emotional undertone for the battle of industry. It was a war fought not only with machines and chemicals, but with minds, endurance, and ingenuity. The heart of the synthetic rubber effort lay in polymer chemistry. Buna-S and GRS were the primary compounds developed, each requiring precise control of temperature, catalyst, and polymerization times. The processes were delicate. Too much heat or too little catalyst could ruin a batch. Chemists experimented tirelessly, refining formulas that could mimic the elasticity, durability, and heat resistance of natural rubber. Facilities were designed for scale. Continuous mixers replaced small laboratory flasks. Polymer was extruded, cooled, and formed into sheets or pellets, then sent immediately to tire and hose manufacturers. Standardization was crucial. Every pound had to meet strict military specifications. Quality control labs operated simultaneously, testing samples for tensile strength, elasticity, and chemical stability. Any deviation could compromise the performance of tanks, jeeps, or aircraft in the field. Japanese technicians, trained primarily in natural rubber extraction, were unprepared for the synthetic methodology. Reports captured in intercepted cables revealed disbelief. Their chemists create substance from chemicals, yet it functions identically to rubber from plantations, one official wrote. The technological gap, once considered theoretical, became a practical battlefield advantage. Synthetic rubber was no longer an experiment. It was a functional, reliable, and strategically decisive material. Producing synthetic rubber in a lab was one challenge. Delivering it to the front lines was another entirely. The War Production Board coordinated a vast network of factories, railways, and ports to integrate this new material into existing supply chains. Standardized pallets, custom rail cars, and warehouse organization ensured that every ton of synthetic rubber moved efficiently from the plant to military depots. Truck and aircraft production depended on this material. Factories producing jeeps, tanks, and aircraft components received scheduled deliveries daily, guaranteeing uninterrupted assembly. Engineers developed contingency plans for potential production bottlenecks, and maintenance crews were trained to work with synthetic rubber components, which behaved slightly differently than natural rubber under extreme heat or cold. Japanese strategists had assumed that disrupting natural rubber supplies would cripple American mobility. Instead, they watched in shock as synthetic rubber flowed seamlessly into every vehicle and aircraft, maintaining operational readiness across multiple theaters. The U.S. industrial machine had transformed adversity into advantage, and every logistical connection strengthened the nation's capacity to fight. From Tokyo to Singapore, Japanese engineers and military officers faced a growing dilemma. Intercepted reports, photographs, and technical diagrams suggested a reality they had not anticipated. America could replace the strategic resources the Axis had assumed were secure. Each new batch of synthetic rubber arriving at U.S. ports deepened their anxiety. How could a nation without access to rubber plantations sustain vehicle production, aircraft readiness, and operation mobility simultaneously? This disbelief translated into strategic miscalculations. Plans to isolate the Pacific Theater through resource denial failed to account for American industrial ingenuity. Japanese command meetings revealed frustration and confusion. Officers scrolled through tables of production numbers, comparing them to prior assumptions, and found them impossible to reconcile with the limitations they understood. Their shock was palpable. What they considered an Achilles heel was no longer a weakness. It had been neutralized. American commanders quickly recognized that synthetic rubber was not merely a chemical breakthrough. It was a strategic force multiplier. General George C. Marshall and other high-ranking officers incorporated its availability into operational planning. Entire campaigns, previously constrained by vehicle and aircraft maintenance concerns, could now move forward with confidence. Logistics officers recalculated deployment schedules, factoring the reliable delivery of tires, hoses, and other critical components made from synthetic rubber. The presence of this material allowed U.S. forces to maintain mobility in theaters where roads were treacherous, jungles impassable, and supply lines stretched across thousands of miles of ocean. Tanks could roll continuously. Aircraft could remain operational. Trucks could carry troops and supplies to forward positions without fear of rubber shortages grounding them. Leadership recognized that this technological innovation gave American forces not only material advantage, but also operational flexibility. The ability to act faster, strike deeper, and sustain operations longer than the enemy became a decisive element in planning engagements across both the Pacific and European theaters. Japanese commanders, by contrast, faced an unanticipated problem. Their plans relied heavily on denying America access to critical resources, with synthetic rubber compensating for the loss of Southeast Asian plantations. Their calculations were obsolete. Every strategic assumption about U.S. mobility and resilience had to be reassessed under growing disbelief. The first tangible impact of synthetic rubber appeared on the battlefield months after production began. In the jungles of New Guinea and the islands of the Central Pacific, U.S. troops relied on vehicles that previously were faltered due to worn tires or damaged hoses. Tanks could traverse muddy roads without a mobilization. Jeeps carried reconnaissance teams into previously unreachable terrain, and aircraft engines remained operational under sustained sorties. Every deployment reinforced the invisible advantage provided by synthetic rubber. For Japanese forces observing these movements, the effects were disorienting. Ambushes intended to exploit U.S. mechanical vulnerabilities failed repeatedly. Vehicles pressed forward where natural rubber shortages should have caused delays. In military logs and post-action reports, Japanese officers noted with incredulity the resilience and constant operational tempo of American forces. Tactical superiority, once dependent on geography and preparation, was increasingly influenced by an unseen but crucial industrial resource. Synthetic rubber production also bolstered morale on the home front. Factory workers, many women who had entered industrial labor for the first time, took pride in their contribution to victory. Each ton of synthetic rubber produced was celebrated in local newspapers as evidence of American ingenuity and determination. The narrative of overcoming scarcity resonated with citizens, reinforcing national resolve. In Japan, intercepted broadcasts and reports suggested growing frustration and disbelief among both military planners and the civilian population. The expectation that America would falter under resource constraints was proving false. The contrast between the Japanese reliance on natural resources and America's capacity to engineer replacements highlighted not only a tactical and technological gap, but also a moral and psychological one. The home front industry and workforce became integral components of national strength, demonstrating that warfare extended beyond the battlefield into chemistry labs, factories, and supply chains. Beyond immediate wartime impact, synthetic rubber showcased the transformative power of industrial innovation. U.S. factories demonstrated that centralized coordination, rapid technological scaling, and integration of research into mass production could overcome even the most severe material shortages. This model of industrial warfare would influence post-war economic and military planning, laying the groundwork for future advancements in synthetic materials, logistics, and supply chain management. Japanese engineers, while initially stunned, later studied these processes post-war. Reports highlighted the speed, scale, and precision with which Americans had replaced a critical natural resource. The lessons were clear. Technological ingenuity and industrial coordination could decisively shift strategic balance, a realization that would influence global industrial policy for decades. Summer 1943. The Solomon Islands are hot, humid, and unforgiving. Dense jungles rise sharply from coral-strewn beaches. Rivers cut through the thick vegetation, and muddy trails twist across ridges where American and Japanese forces converge. In the U.S. command centers in Brisbane and Port Moresby, officers study maps and reports, confident in the operational readiness of their vehicles and aircraft. Every unit, from armored divisions to reconnaissance teams, has been supplied with components made from synthetic rubber. Tires are reliable, engine hoses intact, and aircraft seals secure. The flow of material has eliminated the mechanical limitations that had plagued earlier campaigns. On Guadalcanal, the difference is immediately tangible. Trucks carrying artillery navigate mud without stalling. Tanks advance over terrain that would have bogged down natural rubber tires. Engineers report that hoses and belts in aircraft engines remain intact despite extended flights in extreme heat. The previously anticipated shortages, delays, breakdowns, immobilized vehicles never materialize. Commanders can concentrate on tactics, not repairs. U.S. forces gain ground faster, striking Japanese positions with sustained pressure. Meanwhile, Japanese engineers, receiving intercepted reports and reconnaissance updates, begin to grasp the scope of the American advantage. Units they expected to be immobilized are advancing without hesitation. Japanese field reports note, their vehicles move as though supplied by endless plantations. Our sabotage efforts are ineffective. The disbelief and shock extend from technical staff to frontline commanders who find that anticipated weaknesses have vanished entirely. The strategic impact becomes evident in the Battle of New Georgia. U.S. armored units, fully operational thanks to synthetic rubber, outmaneuver Japanese positions. Tanks and artillery move along previously impassable jungle roads, supporting infantry advances and securing key airfields. Aircraft sorties are sustained for days, maintaining air superiority and disrupting enemy supply lines. Japanese forces, expecting attrition through resource shortages, are forced to react to an opponent whose material readiness appears limitless. Behind the scenes, U.S. logistics officers continue to orchestrate the flow of synthetic rubber. Plants in Akron, Houston, and Baton Rouge are producing at full capacity. Railways transport finished materials to ports, where ships carry them to Pacific depots. Every shipment ensures that armored columns, trucks, and aircraft remain operational. The synchronization between industrial output and frontline needs transforms what could have been a logistical nightmare into a decisive operational advantage. Japanese military planning falters under this pressure. Attempted ambushes and roadblocks designed to exploit supply vulnerabilities fail. Vehicles roll through mud and obstacles without delay. Aircraft conduct continuous sorties without concern for component failure. Commanders who relied on the assumption that America's rubber shortage would create strategic paralysis confront a harsh reality. The U.S. had replaced a critical resource with synthetic innovation, and their own advantage had been nullified. In this crucible, the tactical and technological advantages merge. Human ingenuity, industrial capacity, and battlefield application coalesce to deliver a force capable of overwhelming positions previously thought secure. Every maneuver, every advance, every coordinated strike underscores the importance of synthetic rubber, not as a laboratory curiosity, but as a decisive factor shaping the war's outcome. By the end of the first phase of the new Georgia campaign, Japanese engineers' reports are filled with incredulity. Officers in Tokyo read telegrams describing fully operational units, unbroken supply lines, and vehicles performing flawlessly in hostile environments. The reality contradicts every expectation. What they had assumed would be a crippling deficiency for America, the loss of natural rubber, is instead a strength, reshaping their tactical calculations and forcing hasty adjustments across multiple theaters. The human, technological, and strategic threads converge here. American soldiers, supplied with synthetic rubber components, are mobile, adaptable, and relentless. Japanese forces, expecting a vulnerability, encounter an unbroken logistical network and an operational tempo they cannot match. The psychological effect is profound. Disbelief, frustration, and an acute awareness that their assumed advantage has been neutralized. Late summer 1943. The Japanese defensive lines across the Solomon Islands are stretched thin. Communication between isolated units is unreliable, resupply is slow, and morale is beginning to fracture. Japanese officers had assumed that U.S. units would encounter frequent mechanical failures due to rubber shortage. Tires would burst, engine hoses fail, artillery transport wheels seize. But those assumptions proved catastrophically wrong. Every vehicle, every truck, every aircraft was operating at full capacity, thanks to the uninterrupted supply of synthetic rubber. At Munda Point, U.S. infantry advanced with armored support that had once been impossible in the jungle terrain. Tanks roll along mud-choked roads, artillery pieces are towed without delay, and reconnaissance jeeps deliver critical intelligence to commanders on schedule. Aircraft overhead maintain constant air cover, their engines and control systems fully operational, because hoses and seals remain intact. Every movement demonstrates the hidden power of synthetic rubber. A material that had once existed only in laboratories is now a decisive battlefield enabler. Japanese engineers and officers, reviewing captured documents and intelligence reports, are forced to confront a reality that defies expectation. Intercepted telegrams note, "They have overcome nature itself. Our efforts to halt them are meaningless." Reports emphasize the unbroken flow of vehicles and supplies and the inability of sabotage or terrain to hinder U.S. mobility. Engineers in Tokyo are incredulous that a synthetic substitute, produced under wartime pressures and in record volumes, can function as reliably as the lost natural rubber. The operational consequences are immediate. Japanese defensive positions, carefully designed to exploit delays caused by mud, broken tires, or impassable terrain, are systematically outflanked. U.S. units maintain momentum, advancing faster than anticipated. Every failed ambush, every overrun defensive point, underscores the strategic advantage synthetic rubber provides. What Japanese planners had expected to be a limitation is now an enabler of sustained offensive operations. The psychological impact is equally profound. Japanese commanders recognize that their previously reliable assumptions about American vulnerabilities are obsolete. Frontline officers report frustration at their inability to anticipate or counter U.S. maneuvers. Plans that depended on attrition caused by mechanical breakdowns or delayed supply convoys crumble in real time. Field reports describe an opponent who appears unstoppable, not because of greater numbers or superior tactics alone, but because their industrial base had converted a material deficiency into operational dominance. At sea, American supply ships continued to deliver synthetic rubber across thousands of miles of ocean. Each shipment reinforces frontline units, allowing engineers and mechanics to maintain vehicles and aircraft in optimal condition. This logistical continuity creates a feedback loop. Mobility enables faster advances, which in turn creates opportunities to seize enemy positions and consolidate control, further compounding Japanese strategic challenges. In New Georgia, Vella La Vella, and across the Solomon Islands, Japanese officers witness repeated proof of this reality. U.S. forces execute operations with precision, timing, and reliability unmatched by enemy expectation. Tanks that should have been immobilized navigate jungle tracks. Artillery pieces reach forward positions on schedule, and aircraft remain operational for extended missions. Every engagement highlights the operational impact of synthetic rubber, transforming what could have been a logistical vulnerability into an unassailable strength. By the end of the campaign's first phase, Japanese engineering and military assessments are filled with astonishment. Reports repeatedly emphasize disbelief. Our calculations assume shortages, yet their forces operate as though no limitation exists. Tactical ingenuity, previously relied upon to offset American numbers and equipment, is nullified by the sheer reliability and volume of synthetic rubber supply. The strategic balance in this critical theater has decisively shifted. The convergence of chemistry, industrial production, logistics, and battlefield application culminates here. Synthetic rubber has moved from an experimental material into the heart of American warfighting capability, enabling decisive operational tempo and forcing the enemy into reactive, often futile maneuvers. American forces now possess an advantage that cannot be countered with conventional methods, an invisible yet unstoppable force born in laboratories and factories and proven on the battlefield. By late 1943, the consequences of America's synthetic rubber production were undeniable. U.S. forces, now fully mechanized across the Pacific theater, maintained a pace of operations previously thought impossible. Tanks, trucks, and artillery pieces moved reliably through mud-choked jungles and over coral-strewn beaches. Aircraft engines operated without interruption, enabling continuous air cover and reconnaissance. Every advance, every successful resupply, every operational victory traced back to an invisible advantage, the uninterrupted supply of synthetic rubber. For Japanese forces, the reality was grim. Officers reviewing interceptor reports and post-battle assessments could see that their strategy of resource denial had failed. Every obstacle designed to exploit material shortages, the terrain, ambushes, or planned interdiction of supply lines, was rendered ineffective. Vehicles advanced where they should have stalled, aircraft sorties continued despite extreme conditions, and artillery units arrived at positions on schedule. The strategic assumption that America's mobility would be constrained by the loss of natural rubber had been completely undermined. Casualty and production reports reinforced the broader consequences. U.S. military units sustained operational readiness at levels unmatched in prior campaigns. The availability of synthetic rubber allowed for extended engagements without the typical attrition from mechanical failures. Units in the Solomon Islands, New Guinea, and other forward areas moved with a confidence rooted not only in training and discipline, but also in the reliability of every component supplied to them. Supply lines remain intact, and operational tempo remain unbroken, creating a continuous cycle of pressure on Japanese defensive positions. On the home front, American industrial capacity had reached unprecedented levels. Factories in Akron, Houston, and Baton Rouge continued producing synthetic rubber at scale, and logistical networks ensured rapid transport to depots across the Pacific. The workforce, including tens of thousands of women entering industry for the first time, had proven capable of sustaining high-output operations under intense pressure. Public support, reinforced by news reports highlighting technological achievement and industrial ingenuity, bolstered morale and national confidence. Synthetic rubber became a symbol of American resilience and adaptability, proof that the nation could overcome material shortages through science, planning, and coordinated labor. For Japanese engineers, the shock continued even after the campaigns concluded. Technical reports compiled in late 1943 emphasized the scale and reliability of American production. One intelligence summary noted, despite losing access to natural plantations, their capacity to supply frontline units exceeds expectations. Our assumptions about attrition and delay have been invalidated. These assessments underscored a fundamental shift in the industrial balance of power. America had not only replaced lost resources, but had done so on a scale sufficient to support sustained offensive operations. The operational implications extended beyond immediate campaigns. Synthetic rubber allowed U.S. forces to maintain mechanized mobility across multiple theaters, reinforcing strategic flexibility. Battles that might have been delayed or limited by mechanical failure were executed with precision. The ability to supply forward units reliably meant that commanders could plan longer, more ambitious operations, confident that equipment would perform as expected. This advantage, subtle but decisive, became a cornerstone of U.S. strategic planning and contributed to successes that would resonate throughout the remainder of the war. Japanese forces, meanwhile, were forced to adjust their calculations continuously. Attempts to disrupt supply lines, sabotage equipment, or anticipate mechanical delays proved increasingly ineffective. The technological and industrial advantage conferred by synthetic rubber had reshaped the battlefield. Japanese defensive strategy, once confident in America's material vulnerabilities, now contended with an opponent whose operational resilience appeared limitless. In retrospect, this period highlighted the decisive interplay between industry, innovation, and warfare. Synthetic rubber had moved beyond the laboratory to become a tangible force multiplier, influencing battlefield outcomes, shaping strategic decisions, and altering the trajectory of entire campaigns. The success of U.S. production demonstrated that technological innovation, combined with coordinated industrial execution, could overcome even the most severe resource challenges, leaving the enemy struggling to respond to realities that defied their calculations. As 1944 approached, the long-term consequences of synthetic rubber production became increasingly clear. U.S. forces were no longer constrained by the loss of natural rubber. Across the Pacific, mechanized units operated continuously, moving men, artillery, and supplies with unprecedented reliability. Armored divisions advanced along jungle tracks without delay, reconnaissance teams penetrated enemy positions efficiently, and aircraft remained operational for extended sorties. Every engagement reinforced the invisible advantage conferred by synthetic rubber, enabling sustained momentum and operational flexibility. For Japanese forces, the impact was both strategic and psychological. Frontline commanders recognized that conventional methods of resource denial, once a cornerstone of defensive planning, were ineffective. Ambushes intended to immobilize vehicles failed. Supply interdictions went unheeded, and anticipated mechanical attrition did not occur. Reports from engineers and officers repeatedly emphasized shock and disbelief. Their forces move as though no limitation exists. Our efforts to hinder them are futile. The Axis assumption that control over natural rubber plantations would decisively weaken U.S. operations had been completely overturned. The failure to anticipate American industrial ingenuity contributed to operational setbacks. Japanese troops faced relentless advances and sustained attacks, unable to compensate for the mobility and resilience of U.S. forces. Attempts to disrupt supply chains or exploit mechanical vulnerabilities were increasingly ineffective. Commanders on both fronts found themselves reacting to a force whose preparedness and operational capacity exceeded expectations, creating a reactive posture that eroded initiative and morale. Beyond immediate military outcomes, synthetic rubber also left lasting lessons in industrial strategy. The U.S. had demonstrated the capacity to mobilize science, labor, and logistics into a coherent force multiplier. Coordination between chemical engineers, factory managers, logistics officers, and frontline commanders ensured that innovation translated directly into battlefield advantage. This model of industrial integration would influence both military and civilian sectors in the post-war era, establishing frameworks for mass production, research-to-industry pipelines, and strategic resource management. Japanese post-war assessments reflected this reality. Reports reviewed decades later highlighted the scale, speed, and reliability of American synthetic rubber production as a decisive factor in Pacific operations. Analysts concluded that while Japan had successfully captured the world's largest natural rubber supplies, America's ability to replace the resource with synthetic alternatives nullified this advantage. The result was a fundamental recalibration of strategic expectations, demonstrating that industrial adaptability could decisively shape the outcome of modern warfare. The operational, technological, and psychological consequences converged to produce a clear outcome: U.S. forces could maintain mobility, sustain offensive operations, and apply pressure across multiple theaters simultaneously. Japanese strategies, relying on assumptions about resource limitations, were repeatedly frustrated. The war in this context was as much a contest of factories and laboratories as it was of soldiers and terrain. In the Pacific, as in other theaters, synthetic rubber became a silent but decisive participant. Each tire, hose, and gasket represented countless hours of labor, ingenuity, and planning, an invisible advantage that sustained operations and shaped battles long before the first shots were fired. For the Japanese, the realization that industrial innovation could override strategic resource control was both humbling and devastating, underscoring the shifting balance of power. Ultimately, this period highlighted the interplay between technology, logistics, and strategy. Synthetic rubber was not merely a substitute for a lost resource. It became a force multiplier, reshaping operational planning and altering the trajectory of campaigns. The ability to overcome scarcity through innovation became a defining feature of U.S. wartime success and a lesson for generations to come. The story of synthetic rubber in World War II is not just a tale of chemistry or factories. It is a story of human ingenuity and industrial resolve. In laboratories across America, chemists transformed raw chemicals into materials that could replace a critical natural resource lost to enemy conquest. In factories, thousands of workers labored tirelessly, often under hazardous conditions, to turn scientific theory into operational reality. Their collective effort became an invisible yet decisive weapon, enabling troops to move, fight, and endure where nature and geography might have otherwise constrained them. For Japanese engineers and military planners, the sudden realization that the supposed advantage of controlling natural rubber had been nullified was profound. Their disbelief underscored a central truth of modern warfare. Technological and industrial innovation can decisively alter the battlefield before a single shot is fired. The war had shifted not only in the Pacific jungles and on the oceans, but also in laboratories and factories far from the front lines. The silent power of synthetic rubber illustrated that victory could hinge as much on production lines and logistics as on strategy and courage. The lessons extend beyond the battlefield. Synthetic rubber demonstrated how nations can adapt to scarcity through creativity, coordination, and perseverance. It revealed the strategic potential of industrial planning, the importance of integrating science into national defense, and the ability of human determination to overcome material limitations. In doing so, it reshaped not only the course of World War II, but also the future of industrial and military planning in the decades that followed. Ultimately, synthetic rubber was more than a substitute for a lost resource. It was a symbol of resilience, innovation, and the transformative power of human ingenuity. It changed the calculus of war, saved lives, and ensured that the United States could sustain its forces across the vast expanse of the Pacific. And in every tire, hose, and seal, the story of perseverance and foresight endures, a testament to how invisible forces of industry can shape history as profoundly as the fiercest battles.